When we're expanding sets of brackets, I think it's really important that we recognise the fact that every independent term outside that bracket gets multiplied by each term in the second bracket. And I think essentially with something like x plus 2 times x plus 3, we need to establish that there'll be a number of students in an exam that will just say that the answer is x squared plus 6. So they multiply x times x to get x squared and 2 times 3 to get 6. And unfortunately that will not give them the full marks. So when we're expanding brackets such as x plus 2 times x plus 3, I'm going to draw some arrows, an arrow from x to x, an arrow from 2 to 3, and I'm going to draw an arrow from 2 to x, and then I'm going to draw an arrow from x to 3. So the most important thing to establish here is that I've got 4 separate operations to expand brackets such as x plus 2 times x plus 3. And sometimes when we draw the curvy arrows like that, it does look a little bit like an eyebrow, a nose, and a smile. So sometimes students find it quite useful to see this as eyebrow, nose and smile. So I start off, now that I've got the arrows in place, of saying x times x, well that's going to give me x squared. For my second eyebrow, I've got to multiply 2 by 3, and 2 times 3 is 6, so I've got plus 6 there. And then I move on to the nose part, where I'm going to multiply 2 times x, and that gives me 2x, like that. And then I move nice and smoothly towards the end here, because x times 3 is 3x, so I write that as plus 3x there. And I think it's really important in an exam situation that once you expand those brackets, we just check to see if it can be tidied up. So we perform the concept that we call gathering like terms together. I'm looking at this line here and I want to get 100% of the marks on offer. So I know there's an x squared here, so I write x squared. But along here I've got 2x and I've got 3x, so I combine those terms together and that gives me my 5x. So I put plus 5x there, and I've got a plus 6 on the end. So I pop that just there, and my overall answer for this particular bracket expansion is that x squared plus 5x plus 6 is the correct answer. And I've got the highest power of x on the left, then the next highest, and then I put the constant term, the term without the x, on its own. So we have to be very careful to make sure that we multiply each term in this bracket by each term in that bracket. So there's 4 separate things we have to do there before tidying up and obtaining the correct answer. Now, what I've got here is I've got to multiply out x plus 4 and multiplying that by x minus 5. So what I'm going to do for the second example is I'm going to multiply x by x like this. That gives me my x squared. I then multiply my 4 by my minus 5. Now, you have to be careful here because if we've got a plus and a minus together, we know that we have to replace that with a minus. Because if the two signs are different, if it's a plus and a minus, it's a minus. If it's a minus or a plus, we replace it with a minus. So when I do my second eyebrow here, 4 times minus 5, be very careful to write down minus 20. So I'll write x squared minus 20 there. For the nose part, I'm multiplying the 4 by the x, and that gives me plus 4x. And then for the smile part, I'm going to multiply the x by the minus 5, and that gives me minus 5x. Now, just being incredibly careful with the minus signs, I tidy this up now and I say I've got an x squared. Now along here, I've got to be really, really careful. I've got a plus 4x, take away a 5x. And if we think of this as almost like the numbers on a thermometer, we've got 4 degrees and we lose 1 degree, then we can safely say that the 4x combined with the minus 5x gives me minus 1x. Now instead of writing minus 1x, I can just write minus x. And then I pop the 20 on the end, or the minus 20 on the end. And I get a correct answer when I'm expanding those brackets as x squared minus x minus 20, and that's my correct answer. So in this example, I'm going to multiply x minus 6 multiplied by x minus 7. And again, I'm going to multiply the x by the x. I'm going to multiply minus 6 times minus 7, and then manoeuvre towards the nose, minus 6 times x, and then I've got the smile for my eyebrow, nose and smile. And so my 4 terms can proceed as follows. X times x gives me x squared. Then I've got minus 6 times minus 7. Now, if both the numbers are minus, we know that 2 minuses combined can be replaced with a positive. And we also know that a plus plus is also a positive. So the general rule is if the signs are different, we can replace it with a minus. If the signs are the same, then it's a plus. So my second eyebrow gives me minus 6 times minus 7. Well, that gives me plus 42. So I plus 42 there. Then I manoeuvre towards the nose part here. I'm going to multiply minus 6 times x, which is minus 6x. And then I've got x times minus 7, which is minus 7x. So all I now need to do is to gather like terms to tidy up. I've got my x squared, safely secure there. And then I look at my x terms, I've got minus 6x, take away 7x. Well, if we think about it again on the temperature line, minus 6 degrees, and then it gets 7 degrees even colder, takes you way down to minus 13. So I've got minus 13x, and I've got my plus 42 on the end. So I'll just check that everything's sensible here. I've multiplied out 4 separate terms here, so we've got x times x, minus 6 times minus 7, minus 6x, and I've got x times minus 7. So x squared plus 42 minus 6x minus 7x produces x squared minus 13x plus 42. I know that's the correct answer. Now sometimes we have a situation where we have a coefficient or a number before the x. And for this next example, I'm just going to look at expanding 2x plus 3 times 4x plus 5. So we stay calm here and we look at this and we still apply the same principles. And I've got not just 1x here, but I've got 2x plus 3 and I've got 4x plus 5. And I say to myself, okay, what's 2x times 4x? Well, if I just consider perhaps the numbers in a different colour, say the numbers are in a red colour and the x's are in a black colour, and I just focus just on the red, I can see that 2 times 4 is 8. So this first term is going to be 8, and I focus on the black, so x times the x, that's going to give me x squared. So my first term is going to be 8x squared. So 2x times 4x is 8xx, which is 8x squared. This eyebrow here produces 3 times 5, so that's going to give me 15. And the nose here, 3 times 4x, gives me 12x. And then I have the smile here, 5 times 2x is 10x. If I now just tidy things up, I've got 8x squared plus 22x plus 15, which is indeed the correct and final answer. So in summary, when I'm multiplying at brackets, I've just got to make sure that I set up a structure to make sure that in the case of 2 terms from 2 brackets, I've got 4 separate entities there, 4 separate things to do. I expand those brackets using the kind of eyebrow, nose and smile. I gather together my like terms. I get to my correct answer. And I know that I've secured the full marks. So if a question like this comes up, if you keep it nice and clear, show your method work nice and clearly, gather together the like terms, you're going to get the full marks in this question. So all the very best for this question from the Collins team.